assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
30.58. So we have beryllium-7, and it decays with a half-life of about 53 days. And the problem tells us that it gets produced in the upper atmosphere and then sort of falls onto the surface of the Earth. And so we've gone and picked up a plant leaf and found that it's having 350 decays per second from beryllium-7. And so how long do we have to wait? We'll call that our initial decay rate. How long do we have to wait for that to drop to less than 25 per second? And we want to figure out what the initial mass of beryllium-7 was to begin with on our leaf. So the activity is the initial activity times the exponential decay. So the amount of time it takes to reach a specific activity level is going to be -1 over lambda times the log of our desired R over our starting R. So this is going to be 25 decays per second. This is 350. So now 1 over lambda is the half-life divided by the log of 2. And so now we have things that we know everywhere, and so we can put the numbers that we know in. And so we find that we have to wait for about 200 days. So 2.0 times 10 squared days. Now, the initial activity is going to be equal to the decay rate, or the decay constant, times the initial number of beryllium atoms we had. Now the decay constant is the log of 2 over the half-life. And then the number of atoms we had is going to be the starting mass times Avogadro's number in atoms per mole divided by the mass number in grams per mole, and so the per moles on top and bottom cancel out. And so we just solve for the initial mass here. It's going to be the initial decay rate times the half-life times the mass number divided by Avogadro's number times the log of 2. And so we find out that we have a rather small amount, which is probably good because beryllium is pretty toxic, even when it's not radioactive. So 2.7 times 10 to the negative 17, not that lucky, 14th grams.